Hello, and today's purpose of the day is I can use the distributive property and factor by grouping. I can use the zero product property. Let's take a look at a warm-up problem. From page 473, this is number 32. And this problem states that two or more integers, or monomials, with a GCF of 1 are said to be relatively prime. Copy and complete the chart to determine which pairs of monomials are relatively prime. So go ahead and take a few moments here and see if you could complete this problem and see which two monomials are relatively prime. Do you know where to start? Yeah, it would probably be a good idea to find the prime factorization of each monomial. So we need to break down 15a squared bc cubed. And so 15 breaks down into 3 times 5. And then we have a times b and 3 c's. 6b cubed c cubed d breaks down into 2 times 3. And then 3 a's, 3 c's, and 1 d. And 12c squared, or c d squared f, breaks down into 2 times 3 times c times d times 1f. 22 breaks down into 2 times 11, and then we have 3 d's, 1f, and 2 g's. 30 f squared gh squared, and 30 breaks down into 2 times 3 times 5, f times f, g, and then 2 h's. So which monomials here are relatively prime? Again, look at that definition. It says with a GCF of 1. So which two monomials here have a GCF of only 1? Yeah, here if you look at 15a squared bc cubed, that has 3 and 5 and an abc. But then if you look down here at 22d cubed fg squared, that has a 2 and an 11, and then no ab's and c's. It has df's and g's. So those two would be relatively prime. So we would write for our answer 15a squared bc cubed and 22d cubed f g squared. And again, this is just knowing how to break down monomials, figure out their prime factorization, and then know what you need to look for. Today we're going to look at the zero product property. And the zero product property states that if the product of two factors is 0, then at least one of the factors must be 0. So if a times b equals 0, then a equals 0, b equals 0, or both a and b equals 0. We're going to take a look at what this definition looks like in a few examples. So again, we already know how to figure out the GCF and undistribute and also factor by grouping. So we're just going to look here at solving an equation by factoring. So the process that we are going to use is that we will get the equation equal to 0, we will factor, and then we will use the zero product property. So step 1 here says get the equation equal to 0. So on number 1, our equation is already equal to 0 here. See, it equals 0, so that's really nice. So then the second step says factor. And I already have these two factors in factored form because they are already in parentheses, which means that's factored form. So this example to start out with is very simple in that I'm going to use the zero product property and set each, and I should color code these, each factor equal to 0. So I'm going to set x minus 2 equal to 0, and then I will also set 4x minus 1 equal to 0 because I have two separate factors here. They're in their own parentheses. So I'll solve for x and add 2 to both sides and get x equals 2. And then here I'll add 1 and then divide by 4. So again, the zero product property and get 1/4 states that I set the factors equal to 0. And now if I plug them in, I should see that, hey, that this will work and they will equal 0. So if I were to plug a 2 back in, so this would be if I plug a 2 in for x, right here. 2 minus 2 is 0. 0 times any number here would still equal 0. So that would work out. Now on the other side, I got 1/4. So if I plug in 1/4 for x right here, and I can change colors. If I plug in 1/4, 4 times 1/4 is 1, and 1 minus 1 is 0. 0 times whatever this number over here will be will get me equal to 0. So I want to make sure that I solve for both of my factors because, again, the zero product property states that that's how you can solve an equation by factoring and then setting those factors equal to 0. So my two solutions, and I'll put these in bracket form, and I'll practice, you can practice writing your brackets, you'll get better at them, would be 2 and 1/4. Let's look at the next example. I have 4y equals 12y squared. So again, I'm first going to look at the steps I need to take, and I need to get this equation equal to 0. So I'm going to go ahead and move over the 4y. I'll subtract it to get to the other side and get 0 equals 12y squared minus 4y. Now, this polynomial here has two terms. It's a binomial. So I want to take out the GCF, and that's how I'll factor this problem here. So if I factor out the GCF of 12y squared and 4y would be a 4y. So I get 0 equals 4y. Now I have to undistribute. So this brings us back to the lesson from 8.1. And 4y times what gives me 12y squared? Yeah, 3y. And 4y times what gives me negative 4y? A negative 1. So now I have factored, and that was step 1. Or that was step 1 was get the equation equal to 0, which is what we did. Step 2 is factor, and now I'll use the zero product property. So I have two factors here. I have my first factor, which is 4y, and then I have my second factor, I'll change colors, which is 3y minus 1. So I have to set both these factors equal to 0. Like that, and then 4y equals 0. And I have to solve for both of them. So here when I solve, for this first one, I'll divide by 4, and 0 divided by any number is 0. Over here I'll add 1 and get 3y equals 1, divide by 3, so y equals 1/3. And again, if I want to make sure that this will work out, I'll plug my answers back in and make sure that I get the right answer. So let's go ahead and plug in 0. Well, 4 times 0 is 0, and 0 squared is 0, times 12 is 0. So does 0 equal 0? Yes, so that one works. That's usually a pretty easy one to always plug back in when you're with the numbers, when you're trying to check your math answer. But now let's look here at 1/3. So if I plug in 1/3, 4 times 1/3 equals 4/3, right? And then 12 times 1/3 squared. Well, 1/3 squared is 1/9. So 12 times 1/9 is 12/9, which if I simplify, 12 over 9 simplifies to 4/3. So 4/3 equals 4/3. That's good. So that is right. So then here our answer to this problem number 2 would be 0, 1/3. Get both my answers there. Okay, let's look at the last example. Number 3, 20m squared equals 15m. So step 1 is to get your equation equal to 0. So I'm going to go ahead and I'll move the 15m over to the left side this time. So I get 20m squared minus 15m equals 0. And now I'll go ahead and factor out the GCF. So the GCF of 20m squared and negative 15m here would be a 5m. And then now I'll undistribute. So 5m times what gives me 20m squared? 4m. 5m times what gives me negative 15m? A negative 3 equals 0. And now I have to set both of my factors equal to 0. So 5m I have to set equal to 0. And then let's go back to purple. And then I set 4m minus 3 equals to 0. And I didn't say this on the last example, but whatever your degree is, if you notice your degree here, it's 2. So this is a quadratic equation. You should get 2 answers when you're done. So that's a good way to check here with some of these beginning examples. There's sometimes some exceptions when you won't have 2 answers, but we'll talk about those later, and those will be special cases. But we should get 2 answers here. So I'll set 5m equal to 0. And then I'll set 4m minus 3 equal to 0. and then I'll divide by 5. 0 divided by any number is 0. And then here I'll add 3. 4m equals 3. Divide by 4. So I get 3/4 for my answer. So my two answers, and I circled that, but I should write them in bracket form, would be 0 and 3/4. And then remember, always a good rule to check or to check your answer would be to plug your answers back into your original equation and make sure that they both work out and that you've satisfied and got the answer to both of the solutions in your problem. Thanks for listening. Have a great day. Bye-bye.